Assalamualaikum warahmatullahi taala wabarakatuh. How are you?
Alhamdulillah.
Okay, good. Today, I will finish up the Lagrangian multiplier, and then I will discuss the midterm. And then, if I have time, I will give you, we're looking at application of the Lagrangian. So I hope I can do this in 1 hour and 15 minutes, because this is our last class. Okay. Now, where should I go? I haven't. I have to share. Okay. So we are going to look at the application for Lagrangian multiplier. There are 2 applications. If you look at the book, I will follow the book, the examples in the book. There are 2 types of application. One is, both are economics. One is the utility function. That means consumers maximize utility subject to constraint. And the other one is the maximization of production given the constraint of cost. Correct. Okay. Now, if you look at the Lagrangian, I hope you already finished this thing. If you look at the Lagrangian problem, the objective, all right, you have one objective function, and then you have the constraint. Either one of these will be linear, and the other one is non-linear. So if the objective is non-linear, then the constraint is linear. The constraint is non-linear, then the objective is linear. Or in other words, if your objective is linear, then the constraint is non-linear. So one of them is linear, the other is non-linear. It doesn't matter whether it is the objective or the constraint. Because sometimes, you may have the constraint is non-linear. The objective is linear. Okay, so if I have time, we'll look at that kind of example later. So if you look at example number 4, you have the problem here, maximize utility, given the function utility, and then you have the budget line. Now, if you look at this problem, the budget line is linear. Okay, the budget line is linear. You have here 2x plus 4y equal to 40. Now, budget line in economics is a linear function. We know what is the budget line. The budget line is what? The budget line is simply equal to the price of x plus the price of y multiplied by y equal to your income. So that is the budget line. Px is the price of x. Okay, and then Py is the price of y. And then I, you have your income. So here, these 3 here are constants. Px, Py, and I constants. So all of them are constants. The only variables are x and y. So for example, in order for us to get the budget line, let's say given Px is equal to 5, Py equal to 11, okay, income is equal to 500. So therefore our budget line will be equal to what? Our budget line will be equal to 5x plus 11y equal 500. So that is our budget line. So if you look at example 4, what does it mean? You have 2x plus 4y equal to 40. What does it mean? It means px is equal to 2. And then what is py? Py is equal to 4. And then what is the income? Income is 40. All right. So if you look at the budget line, that is the meaning. Okay. The constants are what? The prices, px and py. And then you have the coefficient, the constant on the other side, is not multiplied to the x or to the y. That is your income. Okay. All right. So that budget line is equal to 2x plus 4y equal to 40. Now you look at the figure, the diagram. In figure 14.3, you will see the picture there. The budget line is a linear function, that's a straight line. The intercept y is 10, the x-intercept is 20. So that is the budget line. So that is the constraint. You cannot move that, okay? The constraint is the one that is fixed. So you are going to maximize your utility given the income, 40, and the prices. So how do you find the optimum point? So you want to find the optimum point is just by doing the Lagrangian. So the problem here is I want to find the consumption of x and y that solve the problem. Okay, solve the problem in the example. Solve the problem or find x and y that maximize the utility as per given. Okay, maximize the utility subject to the constraint. Okay, subject to income, to the income constraint. So that is what you want to find. You want to find, in other words, the optimum point. So in terms of the picture, okay, that is given in the figure 14.3. So you can look there. Now, how do you solve it? So we do the Lagrangian. So the budget line, okay, the budget line, what you need to do for the budget line is you have to rewrite the budget line as gxy minus the k equal to 0. So the budget line you need to rewrite as 2x plus 4y minus 40 equal to 0. So you know the income or the Lagrangian. Okay, the Lagrangian is equal to what? Is equal to the objective plus the lambda times gxy minus k. All right. So what you need to do here is the budget line. Okay, the budget. You have to rewrite 2x plus 4y equal to 40 as equal to what? X plus 4y minus 40 equal 0. So that I can put in the Lagrangian. So our Lagrangian is equal to, you're given the budget line or you're given also the utility, there will be x squared, y squared, plus the lambda, multiplied by 2x plus 4y minus 40. Okay, so that is the Lagrangian function. So you find the first order conditions, that means the first partial derivative. The first one is Lx, that is equal to what? Is equal to 2xy squared plus 2 lambda. Okay, set that to 0. So that is our number 1. And then you have Ly, that is equal to what? That is equal to x squared 2y plus 4 lambda, set that to 0. That is our number 2. And then L lambda, that is equal to everything in the bracket. You got 2x plus 4y minus 40 equals 0. That is our number 3. So what do we do from 1 and 2? You write lambda in terms of x and y, and then you substitute into number 3. Okay, so from here, you do that, what do I get? You will get lambda, but you write everything, okay? We write everything so that the steps are shown. So from number 1, I will do the things. So from number 1, what do I get? I get 2 lambda equal to negative 2xy squared. So what is lambda? Lambda is equal to negative 2 over 2 xy squared. So 2 and 2 will cancel out. And then from number 2, what do we get? We got 4 lambda equal to negative 2x squared y. So lambda equal to negative 2 over 4 x squared y cancel out. We got negative 1 over 2. Okay, so therefore, lambda and lambda, they are equal. What do I get? I get negative xy squared equal to negative 1 over 2 x squared y. Okay, so positive, negative become positive. And then you bring the x to one side, y to one side, then what we get would be x in terms of y. So what do? You bring the y to the left, I got y squared over y. You bring the x to the right, I got 1 over 2x squared over x. So what do I get? I get y equal to 1 over 2x, or x equal to 2y. Okay, so you either use y in terms of x or x in terms of y. We substitute into number 3. So I substitute x equal to 2y into 3. Okay, so if you substitute 3, you will get the optimum value that is as per given in the book. You will get y equal to 5, x equal to 10. Of course, you do the work. Okay, that would be our solution. So if you look at the diagram as given in 14.13, that is x and y, that is our budget line. The point will be that point. So that is the optimum point, okay? So that is x star, y star. So that point is the optimum point, we call it E, okay? So the optimum point is just where the slope and the budget line, or the slope of the budget line, to be just equal to the slope of the utility function. So if you look at the diagram at that point E, you will see that slope of the budget line is equal to the slope of the utility function. So how do you get that point? You don't have to do like this, okay? We do by lengthening. Okay. Right. So that is example number 4. Now you move on to example number 5. We have the other example that is to maximize your production. Okay, to maximize your production, what do we have as constraint? That will be the input constraint. That means cost constraint. So example number 5, you maximize the production subject to the cost constraint or input constraint. So you are given the production, and then you are given also cost. So if you look at this example, the cost is not given. So you have to find the cost. So if you look at the production is given as what? F of xy equal to 100 multiplied by x to the power of x and y. So that is nonlinear. So if the constraint is, if the production is nonlinear, okay, this is nonlinear, then the cost would be what? Would be linear. Okay, so our cost is linear. So cost linear, we can find it. So the cost linear function will be equal to what? Will be equal to, just like the budget line, will be equal to the AX plus BY. So the AX, the A is the price of X plus the price of Y. Okay. Now, for cost, you have the inputs, not the output. So the X is, if you look at that example, the X is what? X is labor in units. Y is what? Y is the capital in unit. Okay, capital in unit. So what is the price of X? That is the price of labor. Now, how do you know what is the price of labor? You are given the labor cost per unit. Okay, labor cost per unit is the price of labor. Okay, so labor cost per unit is equal to 160. So the price of labor is the cost of labor per unit. So that is the price of labor. So that's the price of X, right? Which is equal to 160, and the cost of capital per unit is 200. So therefore, our cost function or the cost constraint will be equal to what? Equal to 160X, which is the price of labor, plus 200Y, which is 200, the price of capital, equal to the limiting cost. Okay, the total cost available is 100,000. So that is our cost function, and that is the constraint. And then, in order for us to rewrite the Lagrangian, you bring the 100,000 to the left. I got 160X plus 200Y minus 100,000 equal to 0. All right. So what is the Lagrangian? The Lagrangian will be equal to, if you write it down, Lagrangian equal to, of course, the objective. All right, objective plus lambda multiplied by the constraint 200y minus 100,000. So that is our constraint, and you don't write that first. We write general form before you write that specific function. So you write the general form. Okay, general form is gxy tadi pula apa saya gxy minus k. Tidak. Baik, kalau ada tadi. Oh, patutlah. Nampak benda tu. Okay, gxy minus k. Right, so that is our constraint. Okay, so you write down the specific, the production. So the L is equal to 100 x to the power of 4 over 5, y to the power of 1 over 5, plus lambda equal to 160x plus 120y, 120y, minus 100,000 tu. Ni 100,000 saya tak cukup tempat ni. Alright, 100,000. So that is our Lagrangian function. So you have the first order conditions. Correct. First order condition, you get the Lx, you get Ly, you get L lambda equal. Okay, finish up. The answers are given. So make sure you do it. Okay, don't just look at the example in the book. You have to do it. Okay, finish it up. If you want to lah. If you don't want to do it, that's fine. Okay. Now, finish this up.
Bukan.
Apa dah? Apa dah?
Sir, bukan. Is it 200y, right?
200y. Yeah, 200y. Okay, thank you. No, tadi saya sebut 120 ke 200? Okay, it's 200y. Should be 200 lah. Okay. So sorry for that. Thank you. So that will be equal to 200. Okay. So you finish this up. look at the solution given in the book to make sure that your answers are correct. Okay, so this is your practice. Okay, all right. Now there are only two examples given here. Now, if you look at the same example, okay, the problem from maximizing to become minimized. So example number 4, I can now put it as example number 4 prime. So the same thing, okay, the same thing. I can rewrite, minimize. So now I switch. Okay? I switch. The constraint become the objective. Minimize our expenditure. Expenditure is how much you spend. Okay, that means how much you spend on the good. So that comes from your income. Okay, minimize the expenditure subject to a given utility constraint. So now the constraint is non-linear. Okay, so in this example here, like I said earlier, if the constraint non-linear, objective will be linear. So here this is non-linear, and then the expenditure is the income is linear. So we can switch. Okay, we can switch the problem from maximizing become minimizing. By doing so, you have to switch also the constraint and the objective. So the constraint becomes the objective. The objective now become what? Become the constraint. Okay. So when we do this, then you minimize the objective, the constraint, which is what? Minimize the expenditure. I call it I because I don't want to use another letter to indicate expenditure. Expenditure is simply the income equal to the price of X. So I maintain 2X plus 4Y. So that is our what? That is the objective. So I can write, okay, in terms of the function, minimize income equal to f of xy. So that is our objective now. Subject to, so now the utility, okay, the utility which is u equal to x squared, y squared, I have to put a fixed number here. So I have to put a constant there because now that is our constraint. All right. So let's say, okay, subject to the utility, okay, utility, say u equal to what? 200. Okay, 200. In other words, 200 is equal to x squared, y squared. So that is our constraint. Okay, 200x squared. So what you do now, you rewrite it as per the Lagrangian multiplier. So that becomes x squared minus y squared, x squared multiplied by x squared multiplied by y squared minus 200 equal 0. Okay, so you have the problem, minimize the expenditure, which is our income, subject to utility constraint, okay, subject to utility constraint, x squared, y squared equal to 200. So now your problem becomes minimization problem. And then the constraint is utility, non-linear. The objective is linear, which is our expenditure, income. Okay, all right. So nothing different. You write the Lagrangian, okay? You write the Lagrangian, the same method, the same way as what we did earlier. And then, your Lagrangian is equal to the objective plus the lambda multiplied the constraint, okay? So now you just put in the respective functions. Okay, all right. I want you to write down the Lagrangian function for this problem. Okay, do it now. I give you 1 minute because I already put down everything. So you just need to put in the functions, get the Lagrangian multiplier function. Okay, you got it? So your Lagrangian will be equal to what? Lagrangian equal to, because now I don't have, I don't write things. So equal to 200. So Lagrangian macam ni lah. Our Lagrangian is equal to what? The objective plus lambda multiplied by the constraint. So that will be equal to, now the objective is the expenditure, which is the income. So that is 2x plus 4y. All right? Plus, one can put a bracket there, 20 f of x1. Plus the lambda multiplied by x squared, y squared, minus 200. So that is our objective. So you do the same thing. Okay, the partial derivative, Lx, Ly, L lambda. So this thing here, this is you finish up at home. All right, so this is the one that I give you was one question, not actually one question, something that you have to do. So this is another homework lah. All right, so this is your homework number 2. Finish it up, get the solution. Right. Okay. I just want to show you,